Hey there students, on this clip we're going to go over how to use the properties of logarithm to um, find the approximation of of logarithmic expressions. So let's write down the title of today's lesson, which is we're going to start by writing down the properties of logarithm. So properties of logarithms. Properties of logarithms. Okay, so we're gonna go over just probably two properties first, and then we'll go on after that. So the first one is log base b of xy equals log base b of x plus log base b of y. So remember what I taught you earlier? That when you're multiplying numbers in the real world is the same thing as what? As adding in the log form. Okay? So addition is multiplication. And let's look at, what if we were doing the division case? So what if we had log base b of x over y? What would that be? It's going to be log base b of x. What is the opposite of times? Divide, right? The opposite of the inverse of addition is going to be subtraction. So whenever you're dividing, this is going to be log base b of x minus log base b of y. Remember, when you're dividing numbers, it's the same thing as subtracting your logs. Okay? And then another last one I just like you to note as a side point, we have a log base b of x as the same thing as log base b of x to the a. Remember, the coefficient can become a power, and the power can become a coefficient. Okay? So these are the three properties that we're going to be using for today's notes and classwork. Okay? Alright, so let's apply these properties to a couple of examples, okay? So, examples. These are the instructions. If log base 2 of 3 is approximately 1.58496 and log base 2 of 5 is approximately 2.3219. Find, number 1, log base 2 of 5 over 3. So let's do this one first. Alright, so we're doing log base 2 of 5 over 3. So how can we do this? These numbers are being divided, right? So if you're dividing the numbers in the real world, then what is division in the log world? See here? Division is subtraction. Remember we talked about it? Division is subtraction. So when you're dividing these numbers, what you're doing is you are actually subtracting your independent logs. Log base 2 of 5 minus log base 2 of 3. So the top one comes first, and you always subtract the denominators, okay? Like that. Now we're going to take the independent approximate values and substitute it here, subtract, and that will be our answer. So what is log base 2 of 5? It's 2.3219 minus log base 2 of 3 is 1.58496. We'll simply subtract these two, and that'll give us our result. So we're going to have, well, let's use a calculator here to make sure we don't make mistakes. So we're going to do 2.3219 minus 1.58496. So 2.3219 minus 1.58496. Answer is 0.73694. So it's going to be 0.73694. Okay? So that goes our first answer. Simple and short. Alright? Okay. Now let's consider another example. That answer. Consider an example. What if we had number 2? Log base 2 of 5 over 3 times 2. Okay? Well, if we had that. This is a division, which is a minus, and this is a times, which is a plus, right? So how do we break this down? We're going to break this down as follows. Log base 2 of 5. Now, what is division in the log world? Division is what? Division is subtraction, right? So we're going to be subtracting these two at the bottom, okay? Log base 2, we have to put it in a parenthesis, minus parenthesis, log base 2 of 3 times 2. What is times in the log world? When you're multiplying numbers, right here is the same thing as adding the log. So instead of log base 2, so log base 2 of 3 times 2 is log base 2 of 3 plus, this times becomes a plus, plus log base 2 of 3. Oh, sorry, of 2. Okay? Now, this minus gets distributed to this right here, right? So if we do that, this becomes log base 2 of 5 minus log base 2 of 3 minus log base 2 of 2. Now, I told you earlier, you always minus the denominators. The denominators are always subtracted, okay? Now, we're going to take your approximate logarithmic values and put them here and compute the difference, okay? All right, so what is log base 2 of 5? It's 2.3219. It was given. Minus, what is log base 2 of 3? 1.58496. Minus, what's log base 2 of 2? Uh-oh, it's not given here. Oh wait, we know what this is, right? This is 2 to the 1. And there is a trick that we learned before. When there's base and a number the same, what happens? It cancels out and you're left with the power, which is just 1. So, down. So technically, we know this, we also know that, we can put that here, log base 2, we also know that log base 2 of 2 is equal to 1. We know that also. Okay? Alright, so let's plug all this in a calculator and see what we get as a final result. So we're going to go, we're going to do, okay, try that. 2.3219 minus 1.58496 minus 1. Answer is 0.26306, negative. Okay, so our answer is going to be approximately negative 0.26306, negative 0.23, okay, I forgot already, 26306, 26306. Alright, so there you have it. So, final results. Let's try a slightly more complicated example. Take this out. Alright, number 3. Number 3, let's do, let's find log base 2 of 5 over 2. What is this gonna be? This is a division problem, right? So when you're dividing numbers, what are you doing with the log? Remember, division is minus, right? So log base 2 of the top of the numerator minus log base 2 of the numerator. Alright? We're going to substitute in the approximate values. Log 5 base 2 or log base 2 of 5 is 2.3219 minus log of 2 base 2 is oh wait, it's not on here. We know that this is 2 to the 1, right? Since these two match, it cancel out, right? And then we know that that is just 1. When we subtract this, it's easy to do. We don't need a calculator. It's simply going to be approximately 1.3219. Alright? And that's your answer. Alright, let's try another example. Let's do example number 4. Let's do log base 2 of 6. Alright? So how do we do this one? Wait a minute, there's no 6 here. But can I use this number 2 and 5? And the other thing I know, I also know log base 2 of 2, right? Can I use these numbers to come up with 6? Can I use 3, 5, and 2 to come up with 6, either by dividing or multiplying? Of course I can, right? These two can give me 6. So I can rewrite this as log base 2 of 3, which I know, times 2, which I know. Okay? Now we're going to transform this into the log world, right? Which is equal to, when you multiply numbers, as this property tells us, you're adding the log. So you're going to go log base 2 of 3 plus, okay, log base 2 of 2. Now let's work that out. To work that out, we're going to get, oh wait, it's not equal. We're going to start using the approximate values now. Alright? So for this one, log base 2 of 3 is 1.58496 plus, these two are the same. Cancel out, so it's just going to be 1, right? It's just 1. And our final answer is approximately going to be 2.58496. Okay? So anytime the number is not exactly what is given, you have to play the game of determining what combination of the knowns yields the logarithmic number that's under consideration. And that's how you do it. Okay? Alright, that's it for the first part of this video. Alright, welcome back, students. In this clip, we're going to be, in the second part, we're going to be going over how to use the properties we just learned to solve logarithmic equations. Okay, so right on the title of this lesson, solving log equations using properties. Okay? Alright, in this, so all I needed to remember is that when you're multiplying numbers, in the real world is the same thing as adding in the log world, right? And when you're dividing numbers in the real world, is like, it's as though you were subtracting. Okay? Alright, so let's try out an example number 1. Example 1. Solve log base 2 of x plus log base 2 of 5 equals 3. Okay? So, let me write this file a little bit bigger so it's obvious what we're doing. So in this case, we want to solve for x. So in order to eliminate the logs, they must be consolidated first. Okay, so you consolidate and then eliminate. Okay, let's make a side note. So we're going to consolidate, and then eliminate. Okay, just like if you want to eliminate. If you want to eliminate your debt, uh, you consolidate it first, right? So we have to consolidate the logs into one and then eliminate it. So how do I consolidate this log right here and this log? I know that the relationship between them in the log world is addition, okay? So if I'm adding logs, what am I doing with the numbers or the arguments? I am multiplying them. So since these logs are being added, this number and this number that is you're taking the logarithm of will be multiplied. So this becomes log raised 2 of x times 5. Well, you write it as 5x, right? 5x equals 3. Alright, so I just consolidated using the first property we went over. Consolidated this log into 1. Since it's now nicely consolidated, now I can eliminate it because it's just 1. Alright? So what is the opposite of log? Is exponent. The basis of exponentiation, the base is 2. So put a big 2 here. Put a big 2 here. Everything else becomes exponentiated. So you have a little log base 2 of 5x and a little 3 here, there, like that. Okay? On the left side, the 2 and the log base 2 cancel out. So you have 5x, and then 2 to the third is 8. Okay? To get x by itself, you just divide both sides by 5, and then your answer is x equals 8 over 5. Okay? So you see what we did? We consolidated it. Consolidated these two logs into one, which made it easy to eliminate. Alright, let's try another example. Example 2, slightly more complicated. Example 2. Solve log raised 2 of x equals 1/2 of log raised 2 of 64 plus 1/2 of 1/3. Sorry, 1/3 of log raised 2 of 27. Okay? Alright, write it down. This is what we're going to do next. Alright, so let's see. Remember the rules again. If you want to eliminate the logs, they have to be consolidated first into one, right? So, we have the nice consolidated log, just one log on the left side, which is perfect. But when on the right side is not consolidated, and it's also messy. What do I mean by it's messy? You have a number in front. I don't even need that, okay? So first thing we're going to do is make it clean. Alright, clean up the logs by getting rid of these coefficients, and then we'll consolidate and then eliminate. Okay? So this is what I'm going to do. I'm going to clean up. Okay. I'll clean up, consolidate, and then eliminate. Okay? Alright, so how are we going to clean up those logs? Well, we're going to use the last rule I told you, which is that the coefficients of a log is the same thing as the power of the number. So everybody put this arrow here. See, this coefficient is going to become a power of the number. There. Okay? And this coefficient here is going to become a power of this number. Like that. Okay? So we're going to have log base 2 of x equals log base 2 of 64 to the 1/2. Okay? Plus log base 2 of 27 to the 1/3. Okay? What is 64 to the 1/2? Remember, if you have a fractional power, the top is the power and the bottom is the root, right? So 64 to the 1/2 is just the second root of 64. And 27 to the 1/3 is just the third root, right? So in this one, we're going to bring out the left side since it's already consolidated. Equals log base 2 of the square root of 64 raised to the first power. Because 2 means, for 2 for square root, you don't need to put any number, right? You just leave it like that. And then 1 is a power plus log raised 2, same story here. The third root this time. For 3, you have to actually put the number there, right? The third root of 27 raised to the first power. Like that. Okay? What I'm trying to do here is I'm trying to clean up the logs so I can consolidate them. So bring down the left side, log raised 2 of x equals log raised 2. The square root of 64 is what? 8, right? 8 to the 1 is 8 plus log raised 2. What is the third root of 27? One number going to times by itself 3 times to get 27. 3, right? So it's going to be 3. If you don't know, you can use a calculator or just play with numbers. Like that. Now we've cleaned it up. Yay. Now let's consolidate. To consolidate, remember when you're adding logs, what are you doing in the real world? You were multiplying. Remember, addition. Multiplying in the real world is addition. The long point, okay? So let's consolidate using that rule. Bring down the left side. It's going to be log raised 2. I'm dealing with the numbers you're taking the logs off, which is 8 and 3. So instead of 8, we're going to simply multiply it, right? 8 times becomes 8 times 3. Right? You can just multiply it. I'm trying to show you all the steps. That's why I'm putting all the steps. So what do we have? We have log raised 2 of x equals log raised 2 of 24. Okay? Now it's nicely consolidated on both sides. Now let's eliminate. What is the opposite of log? Exponents. We're going to exponentiate both sides using what has the base. The base is 2 and 2. So put a big 2 here. And a big 2 here. Everything else gets exponentiated, so you're gonna have a little log raised 2 of x and a little log raised 2 of 24. Okay? So on the left side, this 2 and that 2 cancels out, you're left with x equals, on the right side, this one's cancel out, x equals 24, and of story. Okay? So that's how this works. Alright, thanks for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure. Okay?